Now let us understand the linear regression model. As part of this, let me first take you guys back to your school days and ask you this question on what is the equation of line. You all remember that equation of line is y is equal to mx plus c, where c is called as constant or intercept, and m is called as slope. We used to have the graph in this way. We used to use that graph to plot values. If you remember, school days or college days, we used to take this graph book to our school, and then there used to be small gradients, and then looking at those gradients you used to plot, draw equation of the line, so on and so forth. Yeah, hope you guys remember that. So that is the same logic based on which predictions happen, and we have learned about building prediction models not now. We have learned about that in our school days itself, and now we are practically implementing that by just revising the concepts. On similar lines, there is this equation, regression equation, called y is equal to beta naught plus beta 1 x plus epsilon. This beta 1 is equivalent to c, and this beta naught is called as intercept value or constant. And both this beta naught and beta 1 values put together are called as coefficient values, or these are also called as parameters. Coefficient values are parameters or estimates. Coefficient values, parameters or estimates mean the same, and your beta naught value is given a name called intercept or constant. And this epsilon is called as an error term, which we'll anyways discuss moving forward. But this error formula for this is predicted value, or let me erase everything and then write this. This is predicted value minus actual value. You'll understand all of these things moving forward as in how we build a very good prediction model. So let us do this. And here is a formula given to calculate your beta naught and beta 1. And you know that if you know x and y variables, you can come up with x square, take a summation of that. If you know x and y, you multiply both and take a summation of that. All these are possible, so you know what is beta naught and beta 1. Substitute in this equation, that is your linear model. But let us try to pictorially understand this. I'll take the same example of calories consumed versus weight gain. And if you plot the data, this is a scatter plot. And if you draw a straight line like that, that is called as equation of regression line, prediction line, or your fitted line. And that is given using y is equal to beta naught plus beta 1 x. Now, this is called as y-intercept. The place where your line intercepts your y-axis is called as y-intercept, and that area is nothing but your beta naught value. And if you draw a slope like that, that is your beta 1 value, the slope. How slant the line is going to determine your slope basically, right? So if the line is like that, it will have a different slope. If the line is like this, it will have a different slope. If the line is like that, it will have a different slope. But the problem here is we need to determine what is the best line which is used for prediction. Should it be like this, the blue line that you see here, or should it be like that, or should it be like this, or should it be like that? There are infinitely many lines which are possible. How do you determine the best line? Best line is determined based on least squares technique, right? Best line is determined based on least square technique. So how does that appear, line? Think about this line. You calculate the distance between this data point to this line, right? How do you calculate the distance? Here also you'll have a point. So how do you calculate the distance between 2 points? If I give you 1 point, this will have an x coordinate value and a y coordinate value. This data point above that also will have the x coordinate and the y coordinate, right? So I'm just enlarging the distance between these two data points, this and this. I'm just trying to enlarge here. Now this has x and y, and this also has x and y. So how do we find out the distance between these data points? The distance between these data points is calculated as follows. Square root of y2 minus y1 whole square plus x2 minus x1 whole square. And this is the distance formula, and it is called as Euclidean distance. Yeah, Euclidean distance is square root of y2 minus y1 whole square plus x2 minus x1 whole square. This will give you one value, right? It will give you a number. In similar fashion, the distance between this data point to the line, this data point to the line, this data point to the line, right? Each and every data point to the line would give you distance value. When you take the summation of all these distance values, you'll ultimately get one distance. Say you're getting a distance as 8.5 or whatever be it. Now draw another line like this and try to calculate the distance of each data point from that line. You'll get another distance. Say that distance happens to be 18. In that way, out of all the possible lines, you choose that line which produces the least distance. What do you mean by that? This line is your predicted line. These data points are your actual values. What do you mean by least distance? The difference between your predicted value, this line, and your actual values is the less. So what do you prefer? You predict a value, and should that predicted value be closer to your actual value, or should it be far away from your actual value? It should always be close, right? Your predicted value should be close to reality. If I predict that the temperature tomorrow will be 23 degrees Celsius, in reality tomorrow, at the end of the day, temperature should be close to 23 degrees Celsius. You predicted that tomorrow temperature would be 23 degrees Celsius. Does not mean in reality tomorrow temperature turns out to be 35 degrees Celsius. That is a huge variance, right? So your predicted value and actual value, they should be close to each other. And what would guarantee that your predicted value and actual values are closer to each other? The difference between this prediction line and the actual values should be less. And the difference between predicted value and actual value is called as error. So less the error, better is your model. And whenever you want to predict a new value, it is represented using a hat. So you see a hat there. That means this is a predicted value. Beta naught hat is a predicted value. Beta 1 hat is a predicted value in that way. So what is this equation might be your question. So this is based on your actual data. So what you do is, even before you predict something, you collect some data. For example, if you want to predict if you want to predict adipose tissue, this Y, I'll go here, sorry. So if you want to predict your adipose tissue based on waist circumference, first you try to collect the historical data. Based on this historical data, you construct a prediction model, which is nothing but, once you do this, whenever there are future values, you substitute in this equation to get the predicted value. But hold on to your horses. We will do this practically, and then towards the end, you'll be able to appreciate on what is the kind of model that we're trying to build.